There are three major kinds of numeric types: integer types, floating point types, and fixed point types. Integer types are for storing whole numbers, that is, numbers that don't have a decimal point or a fractional part. Numbers like 1, 2, 3, and 4. Floating point types are for storing real numbers, numbers like 3.14159 or 147.39. Use floating point storage for applications where the range of mathematical results is more important than the accuracy of a calculation. Fixed point types are for storing decimal numbers that have a fixed precision. This is a special type that is useful in situations like financial applications, where arithmetic functions must return accurate results rounded to a specific number of digits. The distinction between floating point and fixed point types is very important, so let's take a look at an example. In the test database, you'll find a table called numerics. I'll type describe numerics, and that will give us the structure of the table. It has an ID field, and it has 4 numeric fields, 2 decimal and 2 floating point. The decimal types are DA and DB for decimal A and decimal B, and the floating point columns are FA and FB for floating point A and floating point B. There's one row of data in the table. And you'll see it has 4 values, 0.1 and 0.2 in decimal, and 0.1 and 0.2 in floating point. The decimal values have the decimal point in a fixed place and a fixed number of digits after the decimal point. The floating point numbers do not have a fixed number of places after the decimal point, so they just show 0.1 and 0.2. Now, if we take the decimal values, DA and DB, and add them together, say DA plus DB, you'll see we get the expected result. DA is 0.1, DB is 0.2, and DA plus DB is 0.3. Now, if we test this for equality with 0.3, in other words, we're testing the result of DA plus DB against a literal value of 0.3, we should get a true answer. And true would be 1, and false would be 0. So we expect to get a 1 here. So this is what we expected. DA plus DB equals 0.3 is true. Now let's try the same little experiment with the floating point values. Take FA and FB, which are 0.1 and 0.2, and we'll take the sum of FA and FB, which is 0.3, and we'll test it against 0.3 and see if that comes out as true. We notice in this case it is false. 0 means false. We might say, well, if FA plus FB is not equal to 0.3, what is it equal to? Well, let's just take out the equals 0.3 part here and see what FA plus FB is. And that's not really what we expected, is it? It's 0.3, which is accurate to about, 6 or 7 decimal places, and then a bunch of junk. This is not equal to 0.3, and that's the problem. Floating point numbers in all computer systems, not just in SQL, but in all computer systems, floating point numbers sacrifice accuracy for what's called precision. In the mathematical world, precision means something different than what you might think it means in your average colloquial speech. In the mathematical world, precision refers to the number of digits of accuracy. So it's accurate to 6 or so decimal places, but beyond that, it is not accurate anymore. Floating point numbers sacrifice accuracy for what they call precision. Decimal number systems in computers are specifically designed to limit the precision for accuracy. In other words, they will always be accurate to the number of decimal places that you define them to be. They will use specific rules for doing rounding, and this works best and was designed specifically for monetary applications, for applications where money is involved. If you're a designer and you know the difference between JPEG and GIF files, think of this like the difference between JPEG and GIF. JPEG files are great for photographic data, but they sacrifice the precision of the colors. They give you the access to millions of colors, but they sacrifice the accuracy of those colors for the amount of colors that you get. GIF files, on the other hand, great for flat artwork where you've got a limited number of colors because they will very accurately represent up to 255 colors and no more. That's the difference between floating point and decimal. Fixed point types are like the GIFs. They have a limited amount of precision and they are very, very accurate. Floating point types are like the JPEGs. They're able to represent a wide range of numbers and they sacrifice a bit of accuracy for that. This distinction is very important, and the point is, of course, if you're doing monetary applications like banking or accounting or anything like that, make sure that you use the fixed point types, in this case decimal.